Hello everybody. So the RC car is in pretty decent working order. I do want to add some more things to it later, but it's definitely doing what it's supposed to do. I'm not entirely sure how I'm gonna do all this, in the sense that I'm not gonna live code everything because it's just too much. I think I'll just walk through the code a little bit. But yeah, let me know in the comments if you would like me to do that. Again, I really focus on the software. The hardware is not the best job. It's a little bit shabby here and there, but it's also not terrible and it works. Uh, so I got the model from a guy from Belgium, I think, OpenRC, which is pretty much fully 3D printable with a few obvious metal parts, but yeah, it's all self-printed. I also printed the tires from TPU, so that's a flexible material. Doesn't work great. It's still actually too hard. So the grip on this wooden floor is kind of terrible. Um, but yeah, let me show. I You already met the servo for the steering in the last episode, and I can just rotate that left and right. Here I'm using this homemade controller with this is the yeah, steering knob and the throttle knob. I also added two more buttons on the bottom, and you can also press those too. So on the bottom I have a light switch, so I can go to put on the lights in the front and the back on, and also to high beam and off again. I can steer as I shown. I can throttle down, so I move backwards a little bit. And when moving slow, the engine kind of seems rough, so it runs better when it's a little bit faster. But again, you see how much traction the rear tires lose. I also made indicators, which added a little bit of an extra challenge because you need to do the actual blinking, but nothing we can't handle. Let's try to turn it around. The green glow are just the LEDs from the ESP32. You can also see that there's a reversing light, and there's also a brake light that will light up when you slow down and go out after a second or so. So it's not super controllable, but yeah, if you look at the rear tires, you see that yeah, they really spin out easily. So it's not easy to control. There's also just not enough weight, I think, on the front tires. I have a very tiny battery in there. It's the yellow thing on the right side of the car. Trying to get it in front of the camera. So I think if I would have a bigger, heavier one, it would sit a little bit better on the front wheels. But yeah, so this is the hardware part. I do want to add some more things to it. I think it would be interesting to do a bit more with telemetrics, in the sense that the car reports back data to the controller. It does do that now. It's kind of hard to show now, but what happens is that there's a heartbeat signal every second or two or something like that the car sends back, and the red LED will light up on the controller when it didn't get a signal for 2 seconds. So that's pretty nice, but you can put a lot more interesting stuff in that in those messages. So one thing I definitely want to do is make a tachometer, so you can see how fast it is going. And I think if I I would like to do it on both the front and the back wheels, because the back wheels is just basically it's a single gear, so it's the totally equivalent to the engine RPM, and on the front you can see if the car is actually moving. So that's going to be interesting. I did some preparations on using a display on the controller, which is also nice. Yeah, and whatever else will show up. But yeah, that's about the hardware. I can do a quick run by the software. I did, yeah, as I said, I'm not going to live code all of it. That would just be too boring, I think. But it is nice to see how it scales, and indeed the complexity of adding more complex stuff is pretty low. I mean, the complexity is complexity, but it's not like the some of the microcontroller code I've seen that you end up with a bigger and bigger loop with more and more if statements. That's not really the problem. We are really because of the async runtime, you can really split it up and add stuff that's yeah, pretty independent. So let's I'll meet back with you when I have my software set up. See you in a bit. So back to the workbench to have a little bit of a close-up view. I disconnected the battery now, so it can't actually move. The LEDs can work, and the control is now powered over USB. So yeah, as you can see, it's a pretty small battery here. So I should have gotten the bigger one. I thought that this would be enough, but it drains pretty quickly, and also it's just too light. And for the rest, yeah, so I modified the design a little bit. I added this rear part from the design. So I designed it in Fusion 360 and added it. The front side I took the design and I modded it by mostly making holes in it to put the LEDs through, and soldered all of it together and wired it with some resistors. So yeah, let's get to the code. Let's. Oh, did wire up my laptop yet? Let me see. So the code, it's pretty similar to the other things we've done. All right, did some OBS juju. Okay, so it's oh man, that's a little bit big, but it is pretty similar than the usual one. So we have the main file that ends up doing a bunch of initialization, so setting up pins and some channels and timers for the servos. Nothing too wild here, and then just spawning a bunch of tasks like this. So both the sender and receiver have a sender and receiver task. The steering, the motor, so the steering is the servo, the motor is the motor controller. Heartbeat, I'll get to that. The blinkers, so because it actually needs some more logic to blink. The lights, so responding to the light commands, so low beam, high beam, and off. Reverse light, so when it's reversing, the reversing light comes on. So whenever the motor control is lower than the center point, it will consider that reversing, so it will engage that light. I split this in two. One will detect that the car is reversing and send a reverse light command, which will be picked up by the other one. That's this one, the motor monitor, and the reverse light will just listen for that command and switch the light on and off. We could have combined those two in one. And the brake light is... oh, what did I do? The brake light is kind of the same. I should have reordered them. They're also split in two parts, in a controller and a monitor in that sense. And what it does is that when you are slowing down, so whenever the motor setting is lower than the last setting, then the brake lights will go on, and they will stay on for half a second to emulate some kind of braking, because there are of course no actual brakes. And test lights will do a sort of startup sequence. And I'm not sure if we're going to go through all of them. But yeah, let's do a few interesting ones. I think the lights are kind of interesting in the sense that it's a little bit more complicated than you might initially think. Because I am doing the two different versions of the headlights with the low beam like this and the high beam like this, I need to have a channel, pulse width modulation channel for that. So I created a channel. I initialized a channel associated with a pin with the timer, so some high frequency doesn't really matter that much. And I changed the duty. So that's for the headlights. For the taillights, that's just a pin that I put on high and low because I don't need to dim it in any way. So I create this headlight controller struct, which has a duty you can set, so that's for the headlights, and the taillight pin you can just set to low or high. And then there is just that controller. Maybe make this full screen like this. So the headlight controller will just listen to commands, any command, so telemetry or anything else, and it will just await a message. Whenever it is a control message of the type headlight command, it will do stuff, otherwise it will just be ignored, because it will get every message in this system. If it's a headlight command, it will respond to high, low, or off. Well, high will set the duty to max for the light controller for the pulse width modulation of the headlights, and it's set as high for the taillight. For low beam, it will set it to 25, and the taillight high, and for off, it will set it to 0 and sets the taillight low. So no big surprises there. What I do like here is that the fact that I have it on one button and I cycle it, so from on, low, high, that's the one button we had. That's I can try to show it on screen. So this is my homemade controller, and there's the rotary button, and I added another push button here, and that will, I unplugged it. Let's shut up the motor, yeah. But the fact that I have that under one button is not encoded here, right? I can change the layout and it doesn't matter, because the protocol between the controller and the car is just encoded in the headlight command, and it does whatever that does. So that's pretty straightforward. For the reverse light, for example, what I do is that I subscribe to the central message bus. I only listen to motor power commands, everything else I ignore. And if it's below the center position, it's around 30 usually, I should be able to recalibrate it, but doesn't matter, then I will send a reverse light on command, and otherwise send a reverse light off command. So yeah, so there are a bunch of this kind of tasks that only have a subscriber and a publisher, and I do kind of like this sort of stream processing like architecture. For the brake light, yeah, so this also has its counterpart. Let me find it. This one, the brake light controller, that takes ownership of the brake light pin. And it will yeah, listen to brake light commands, only those, the rest it will ignore, and it will set it to high or low. Maybe as an aside, I did embrace using type aliases, so I both for the controller and the car, I started using type aliases. So whenever I use a pin for something, I create a alias here. So the blinker, the headlight, daylight, whatever. I gave it a name here and use that name. Same for the servos here. Just give it a name, because I ended up, especially with the servos, to try to do stuff generically. So I end up with a lot of type parameters, but top level tasks are not allowed to have generics. So I needed to wrap them again in a non-generic function, and that was just messy. And this is basically all I wanted, right? That I don't have to, if I for some reason want to connect something to a different pin, that I have to make sure that I go through all the code base to change GPIO 5 to GPIO 6. I just want one place where I can configure this. So I'm pretty happy with that. And this is a simple solution, and I put all the constants here as well, the timers for the servos and for the LEDs, and also the channels I use for that. So they're kind of one-on-one. And this is the frequency, so that's like 50 hertz for both the motor controller and the steering servo, which is standard. So one thing that's particular, that even though I was quite alert on it, it still bit me a little bit, is that I have the sender and the receiver task. So the sender will listen to the central bus of the car, and whatever comes, it will send over ESP now, and its counterpart, that the receiver, that it will listen to the ESP now receiver, and whatever appears, it will send on the central bus. What bit me was that you should not create loops, right? Because it's everything. Because in the sender where I was before, if you send it to the broadcast address, which I always do, the controller will receive it too. So yeah, you can easily see why that is going to be a problem, because it will never stop. And the fail case is kind of weird, because it doesn't totally break, but it just starts getting really slow, and and some commands still work for a while, and then it kind of grinds to a halt. So that took me longer than it should have to figure that one out. But yeah, so the way I solved it now is that I send only telemetry commands from the car. So I deconstructed here for control telemetry. If it's for telemetry, I send it over the wire, and if it's control, I ignore it. And on the control, it's the exact opposite. I send all the controls and I ignore all the telemetry, which does the job, right? So nothing can make a infinite loop. However, maybe it is better to somehow make another distinction, that you kind of give a source to messages. I'm not sure. I have the feeling that there might be a scenario where you might want to deviate from this. But for now this works, so I'm gonna stick with it for the time being. Anything else? So yeah, that's the most of the network part. We did the lights. The heartbeat is also interesting. So the heartbeat is just the car sending every second a heartbeat message. So basically saying, I'm okay. And that allows the controller to listen to that and to know if the car is even there. So maybe I can show it. Let me go to the full screen then. So it might be hard to see though, but so this is the controller. On the right side of the control, let me point, like here, there's on the top of the board, there's a red LED that will light up if the car is if the connection to the car is lost. So let me unplug the car. Oh, no, yeah, sorry, I unplugged this one as well. Those micro USB are not happy. No, you can't really see it. I'll show it next time. It's what you're seeing now is like that startup sequence, which was easy for debugging purposes to to just know. For example, when you're making all the lights, that it's working without having to mess around with the controller. Was there anything else? Yeah, I'll have a quick look at the controller, which is pretty similar. Yeah, also types, so the pins different, not so many. Main function does some initialization, spawns a bunch of tasks. Sender receiver I already talked about. The telemetry receiver is here, I think. That will yeah, what does it do? Yeah, it in this case it will listen for the heartbeats, and it has a signal, so that's kind of like a channel with a single value, and it will signal to this tasks that it received that it received a message, and this will just listen for that signal or a timeout, because you do need to respond as well by time going by. If nothing happens, it's also an event in a sense. So if this will respond either if it receives a signal or 1 second elapses, then it will do something, and it will if it's a new message, it will update the timestamp, and then it will calculate how much time has elapsed between the current time and the timestamp. If it's more than 2 seconds, it will set the status pin to high, which will light up the red LED, and otherwise it will turn it off. And yeah, it will just slowly loop once a second. Anything else? Yeah, so if any control has a task, so there is the steering and the motor that has a rotary task. I think we looked into that one in the last episode. And there are some extra buttons for the indicators. So the indicators are oh, it's right here. The pushing down on the rotary knobs, left or right, and it will also do a select, so listen on the left one or the right one. And yeah, it is kind of, it's not really complicated. So if you press the left one, and if it's already blinking left, it will switch off, and otherwise it will start blinking left. And on the right one, well, pretty much the same. Publish a blinking state command, so what the blinker should be doing, off, left, right, or alarm, that they blink both. And this is the headlight button, and this is the other button. I don't really use it, and you use to recalibrate the motor. Doesn't work too great. And then the actual blinking is all, actual blinking of the lights is taken care of in the car. Yeah, that is pretty much it, I think. So I will continue with this project a little bit more. Let me know if there's something you want to see or play with. I want to make a dashboard using the AMOLED ESP32 I used a few episodes ago, to see if I can make a speedometer that you can see at the controller. I already did some of that for the eagle-eyed viewers. right here. I can't really see it. Right here, no, you still can't see it. So about here there is a Hall sensor, so that detects magnetic fields, and a digital one, so it will say magnetic or not. And I took on the wheel, I cut a hole in it and I put in a rare earth magnet. So whenever this passes, it will give a pulse, and you can kind of see it, maybe. Yeah. No, not really. If whenever it passes, it gives a brief. Yeah, I'm just crunching the connector a little bit. Micro USB is terrible. So maybe give it a little bit of space. That is weird. Let me see if it's actually alive. Plug this one in. Yeah. I think, maybe that's it. There's some piece of metal on this that shorts it because it's too close. Live and learn. I'll get to that next time, but it kind of works. So I can use that to give feedback on the speed. And from there on, I would love to maybe do one of the front wheels as well, because the traction is so terrible. Yeah, the fact that the rear wheels are turning doesn't mean the car is moving. So I would like to have a look there if I can maybe make some kind of primitive traction control. Maybe I'll need to insert more magnets to get a better resolution, but I don't know how many events it can take. So those things, yeah, let me know in the comments. I will share the code to all of this soon. I also need to do a bunch of dependency updates, because embedded HAL crate has been released, so I can get rid of all release candidate stuff. So that's something I'll need doing, but there's a little bit. I'm waiting for a release of ESP Wi-Fi, so that should be in a few days, I suppose. And then I'll update all the code. Let me know. Leave a like, please, if you have ideas or feedback. Let me know, and see you next time. Bye all.